Christy Vath. I'm a physician assistant with 20 years in rheumatology. I'm in Seattle, Washington at Seattle Rheumatology Associates. And today we're going to look at how the selectivity of TYK2 and JAK enzyme inhibition influence their safety profiles. So let's start with a 50,000-foot overview. The human kinome compromises more than 500 protein kinases, which play crucial roles in regulating cellular processes through phosphorylation of various substances. Only a fraction has been explored therapeutically, and one family in particular that is important to rheumatology is the JAK kinase family. So this includes JAK1, JAK2, and JAK3, as well as TYK2. So let's look at these molecules. They're phylogenetically related and share structural homology. Each molecule has two different regions that are therapeutically important. There's a pseudokinase, which is a regulatory or allosteric domain, and this is unique to each JAK as well as the TYK2. Think of having a specific key to unlock this. Then you have the kinase domain or conserved catalytic domain that binds ATP. And this is the same across all molecules. So you can have a skeleton key that opens all of those. Traditional JAK inhibitors like upadacitinib, tofacitinib, and baricitinib bind to this catalytic kinase domain. This is nonspecific, and therefore you get inhibition of all four of the JAK proteins, which in turn will have a wide array of downstream effects. However, in the case of TYK2 inhibitors, such as Deucravacitinib or the investigational TAK-279, these bind to the pseudokinase or regulatory domain, and in doing so creates a conformational change called allosteric, which then deactivates the kinase domain. And by doing this, it does not have effect on JAK1, 2, or 3, and therefore less downstream effects. So why is this important, you ask? Well, JAKs are integral to the signaling of numerous cytokines involved in immune regulation. The broad activity affects multiple cytokine pathways simultaneously. So specifically, JAK1 and JAK3 are involved in common gamma chain cytokine signaling. For instance, IL-2, IL-4, and IL-15. These are essential for T cell proliferation and immune regulation. JAK2 is critical for hematopoietic growth factor signaling. Think erythropoietin, thrombopoietin. And then you have TYK2, which is primarily associated with the signaling of IL-2 and IL-23, as well as type 1 interference. As I noted earlier, JAK1, 2, and 3 bind to the conserved catalytic domain, and in doing so impair a wide range of immune and hematopoietic functions. This broad inhibition has raised significant safety concerns, leading to an FDA box warning for increased risks of MACE events, so major adverse cardiovascular events, malignancy, thrombosis, and serious infections. So let's focus on TYK2 inhibitors, specifically Deucravacitinib, since it's now approved for the treatment of psoriasis. We see that by binding to the pseudokinase or regulatory domain, it inhibits TYK2 function and essentially shuts down the kinase domain and therefore has no effect on JAK1, 2, or 3 activity. This selectivity is crucial because TYK2 predominantly mediates the signaling of IL-12, IL-23, and type 1 interferon. These cytokines are central to PSA and psoriasis pathogenesis, but they're less critical to hematopoiesis or broad immune function. As such, TYK2 inhibitors can block pathogenic inflammation without causing a level of immunosuppression associated with our pan-JAK inhibition. There's clinical data to support this. Let's look at the safety in the POETIC trial for PSO 1 and 2 trials for moderate to severe plaque psoriasis. So looking at Deucravacitinib, it showed low rates of serious infections, low rate of serious adverse events, no MACE or malignancy versus placebo or apremilast, and mostly mild to moderate AEs like nasopharyngitis or headache. In a phase 2 psoriatic arthritis trial, Deucravacitinib was again well tolerated. No serious infections, no MACE, herpes zosters, or significant lab abnormalities observed compared to placebo. I look forward to having this in our armamentarium for treatment in the future. Thank you for listening, and tune in by going to the WRAP website or downloading the WRAP app to learn more on TYK2 inhibition. Thanks again.